All right, so in that last video, I was talking about sometimes you don't have to solve for x and dx, and then I tried that example, didn't work out. So here's an example where it works out. This is from, I think it's, you'll see the same problem in your classwork today. So when you see that solution, hopefully it makes sense. So here's the thing, right? So I'm gonna set, here's the function. I'm gonna set u equal to x to the fourth plus 3. Okay, so in that case, what's du? Well, du is 4x cubed, right? So here is a case where I'm not going to want to rearrange this to solve, I'm sorry, dx. Here's a case where I'm not going to want to rearrange to solve for, forgot my dx up here, x and dx. Why? I'm looking at this. U is x to the fourth plus 3, so I know I can plop in a u here, substituting a u. Now here I have x cubed and a dx. X cubed, a different color. I have x cubed and a dx. Well, here I also have x cubed and a dx. So really the only extra thing is this 4. So I can literally plop this new integral in as u to the third, right? U to the third power times du, because it has this x cubed part and it has this dx part. But I have this extra 4. So when I plug in this du, it's putting this 4 that I don't want in here. So what can I do to kind of remove that? Well, I can multiply this whole thing by 1/4, right? Because now that 1/4 canceled out with that 4. So this is much easier to integrate now because I can take out the 1/4 and I'm just integrating u cubed du. So this is just showing you that sometimes you don't need to do that extra step of rearranging everything for dx and x, because that would be horrible here, right? You'd end up with u plus 3 and the 4th root of that, and same with this, right? So you could do that, but you'd end up with an equation that's more complicated. So the first thing I always want you to do when you're using substitution is to look at think about a u and a du that's going to make your substituting look something easy peasy like this, because that's the goal of it, right? If you're substituting and you're getting some crazy equation, it's not helpful, right? And let's say I had decided to make u x cubed, like making the substituting in this here, I would start to notice, well, that would mean du is 3x squared, which isn't helping me here. But I started to notice if I make u x to the fourth plus 3, it's really helping me here because it includes this dx term and it includes this x cubed term. And all I have to do is this little multiplying by 1/4 to make it work nice and easy, right? Because now what can I do? Now I know that this thing is going to be 1/4 times u to the 4th over 4 times, well, not anything, right? Plus c. There's no bounds. So then when I plug that in, I end up with 1/16. U is x to the 4th plus 3, and that's all to the 4th plus c. So that's my final answer there. Okay, so you'll see some examples like that, and that pattern recognition will start to kind of click the more problems you do. Okay, see you next time.